Hello everyone. Welcome to Bright Lab Tutorials. Today, we will learn about laws of exponents. If you're new here, please don't forget to click that subscribe button for more math tutorials. Okay, let's get started. In mathematics, it's easier when notation is concise and convenient. Exponent is an excellent example of good mathematical notation. It is a convenient way to express repeated multiplication. In our example, 2 to the third power. 2 is the base and 3 is the exponent. Exponent tells you the number of times the base is to be used as a factor. So in this example, we'll multiply 2 times 2 times 2. Multiply 2 by itself 3 times. So the answer here is 8. Here are the laws of exponent. X raised to n multiplied by x raised to m. So if they have the same base, all you need to do is add the exponent x raised to n plus m. If you're dividing same base with different exponent, all you need to do is subtract the exponent x n minus m. This one is the power rule. X to the n raised to m. So this one, all you need to do is multiply n and m. So it's equal to x raised to n times m. Here are some of the other examples of the laws of exponents. Okay, we have two different bases, x and y raised to m. The whole quantity raised to m. That is simply, you just have to distribute the exponent to each of the variable. So it's x raised to m times y raised to m. Same is true with division. X over y, this whole quantity raised to m. You have to distribute the exponent to each of the variable inside the parenthesis. So it's xm over y to the m. Now, if you have a negative exponent, this one you have to get the reciprocal of this exponent. So it's equal to 1 over x to the n. This time you'll have a positive exponent. Any number or any base raised to 0 is always equal to 1. Now let's have our first example. X raised to 3 multiplied by 4x times x to the fourth power. You notice that x here and here has no numerical coefficient. Actually, it has. It's actually equal to 1. Okay? So we first multiply all numerical coefficients. So 1 times 4 times 1 gives us 4. And then, since we all have the same base, let's write x. And then add all the exponent. So it's 3. This one has a 1 exponent. So 3 plus 1 plus 4 gives us 8. So the answer here is 4x raised to 8. For our next example, this one, quantity 4a squared b cubed multiplied by the quantity 2ab raised to 6. We have to work first with the numerical coefficient. So here, we have to multiply 4 and 2, which is 8. And then a. And then look at the exponent. So it's 2 plus 1, a to the third power. B, all you need to do is add exponents. 3 plus 6 is 9. So the answer there is 8 a cubed b to the 9th power. Next example. 4x squared divided by 8x cubed. Again, we have to work on the numerical coefficient. So 4 over 8, we simply reduce it. So it will be 1/2. Okay. And then since we have the same base, and it's division, you have to subtract them. So 2 minus 3, which leads us to 1 over 2 x to the negative 1. Again, we have the rule that once it's raised to a negative power, all you need to do is get its reciprocal. So here, the answer will be 1 over 2x. Another example. 2x to the fourth y to the negative 3 divided by 6xy squared. Again, let's work with the numerical coefficient. So we have to reduce it. So it will be 1 over 3. And then since it's division, so for x, we have to subtract the exponent. 4 minus 1. And then for y, negative 3 minus 2. Okay? So here we have 1 over 3 x cubed and y to the negative 5. Okay, again, we have a negative exponent. We have to get its reciprocal. So our answer will be 1 or simply x cubed over 3 y to the 5th power. Okay, another example, x to the 5th y negative 10 divided by x to the negative 3 y to the 5th power. Okay, this one we're working on the negative exponent in the numerator and at the same time a negative exponent in the denominator. Remember, if we have, let's work on with this one in the numerator first. So if we have y to the negative 10, we need to get the reciprocal of this one. So it will be 1 over y to the 10th power. Now, we have to work on this one. This time, the x variable is in the denominator. So it will be 1 over x to the negative 3. Again, we're working with a negative exponent. So for this one, we have to get the reciprocal in order for us to get a positive exponent. So for this one, it will be 1 over its reciprocal, 1 over x cubed. This time, we have a complex fraction. How do we work on a complex fraction? So this one means 1 divided by 1 over x cubed. In fractions, we have to invert this side. So we're going to make it into 1 multiplied by x cubed over 1. So simply, the answer there is x to the 3rd power. Every time you're working with variables with negative exponents, whether in the numerator or in the denominator, if it's in the numerator, you have to bring it down. If it's in the denominator, you have to bring it up. So in this example, we have x to the 5th power times x cubed all over y to the 5th power times y to the 10th. And since these two have the same base, we have x to the 8th over y to the 15th. That's an easy way how to deal with negative exponents. Let's take this example. Negative 30 x to the 7 y to the negative 10 all over 5 x to the negative 2 y to the 4th power. Remember what I told you? When you have a negative exponent in the numerator, you have to bring this one down. While if it's in the denominator, bring it up. So in this case, let's rearrange this. So it's negative 30 x to the 7th x squared over 5 y to the 4th y to the 10th power. Again, let's work on the numerical coefficient. So this one will give us negative 6. And since these two have the same base, add the exponents. It's x to the 9th power. And then for this one, it's 5y to the 10. 4 plus 10 is 14. So it's negative 6 x to the 9 over 5 y to the 14th power. And for our next example, quantity negative 2x to the 5th power raised to 2, x to the negative 3 times 3x to the 4th. Again, let's work on the exponent outside the parentheses. So this means that we have to raise everything inside with that exponent of 2. So this one is negative 2 raised to 2 times x 5 raised to 2. And then just copy the others. Okay, let's work on first with the numerical coefficient. Negative 2 raised to 2 is 4. And we have to multiply this one with 3. So 4 times 3 is 12. And then since we're all working with x's here, okay, This one will give us x to the 10th power. Okay, so it's 10 plus negative 3 plus 4. Okay, so this one will give us 12x to the 11th. I hope you learned something today. Click on the like button and subscribe to my channel. And look for my next video for more challenging examples. Thanks for watching.